Do you feel the vibes?
Right, so now I need to figure out how to get to that point. Well, to get to that point P, I have to go from the origin horizontally a little bit and up a little bit, right? So how much do I go horizontally to get to that point? Root 3 over 2. So that's the x coordinate of that point. Root 3 over 2. And how much do I go vertically? A half. Okay, so fine. Now, as the next example, why don't we find cosine of 30? Cosine of 30 is SOHCAHTOA, right? But now it's just the adjacent, right? Cosine of 30 is what? Root 3 over 2. It's the adjacent. Sine of 30 is the opposite, so it's 1/2. Okay, so what do you notice? Remember how we wrote the coordinate here? The x coordinate was the same as the cosine, right? And the y coordinate is the same as the sine. Okay? So cosine of 30 is the x coordinate. The sine of 30 is the y coordinate. So when you have your rescaled triangles, for the 30 and the 60s, the sides are always going to be either a half or root 3 over 2. So all you have to do is draw the angle and then say, to get to this point, where do I need to go? And the x-axis that you travel on is the cosine. The y-axis that you travel on is the sine. All right, so that's what we're going to do now. So remember, okay, so let's take a look at this. So for the 30-60 triangle, okay, for the 30 or the 60s, your sides are only either a half or root 3 over 2. Those are the only lengths you're going to go. Okay, so let's color code this. This first angle here, the first special angle, is the 30-degree angle, correct? In radian, how much is 30 degrees? Pi over what? Okay, 180 is pi. Pi over 6 is 30. 180 over 6 or pi over 6 is 30. Now, the corresponding angle to this is this one, correct? And also this, and also that, because all four of those are the same distance up or down from the x-axis. So the one on the left-hand side, that's actually 150 degrees. Let's do all the degrees first. So remember, it's 30 away. So this is 210, and this is 330. Okay, I care a little bit more about the radian. Let's talk about radian. So these are the 6s, right? The pi over 6s. So how much is this next one here to the left? How much? 5 pi over 6. And then the next one? 7 pi over 6. And the next one? 11 pi over 6. You got to go all the way to 11 pi over 6. Okay? You go. Well, yeah, 13 you would just be repeating, right? Now you're getting fancy. Okay, so these are the ones. Okay, so when you create a triangle here, okay, basically what I want to do now, you see how when I did my 30-degree, okay, this line, this yellow line intercepts the circle at that point. What I want to do now is I want to figure out what the coordinate is. In other words, I want to figure out how to get to that point. How much do I need to go over and how much do I need to go up? When I trace the route, how much do I need to go over and how much do I need to go up? That creates a right triangle, correct? That's our special rescaled right triangle. That means one of these sides has to be a half, the other one has to be a root 3 over 2. Okay, Sunny, follow me for a minute. Okay, put your calculator down. Okay, so look, I want everybody to look up here for a minute. I need to know for the 30 degree. Now the 30 degree is the smaller angle. You're closer to the x-axis. So you have to say to yourself, okay, to go to that point, do I go horizontally a longer distance or a shorter distance compared to vertically? So what do you think? We go longer horizontally, shorter vertically, correct? Now, our two side lengths were the half and the √3/2. Which one of these is shorter as a distance? This is the shorter and this is the longer, right? Because 1/2 and √3/2. If the denominators are the same, the one is smaller. So that's the shorter, that's the longer. So that means here I go over √3/2 and up a half. So by the time I get to this point, I've gone √3/2 and a half. Okay? Now, let's go over to the opposite side. How do you get to this point? Again, I have to go longer horizontally. So now I have to go to the left, negative √3/2, and up just a half. To get to this point, the 7π/6, again, I have to go to the left longer and down shorter. So negative √3/2, negative 1/2. Here, longer horizontally, down shorter. So positive √3/2, negative a half. Now, here's where we are heading. Suppose somebody asked you for the cosine of 30. Cosine, remember we said, was the x coordinate. So cosine of 30, you're like, oh, to get to that point right here, cosine is the x value. How much do I go horizontally? The longer amount, √3/2. So cosine of 30 is √3/2. Okay? All right, so let's do some more. Why don't we take a look at the 60s now? Later, because the 60s have the same side length, so I want to do these first. All right, so let's do the 60s. So in degrees, this is 60, 120, 240, 300. They're always 60 away from the nearest x-axis. So this is 60 away from here. This is 180 here. 60 away is 120. 60 here. Well, the 150 is 30 away. 30 away. Okay, so now, so this is pi over what now? For the 60 degrees. Pi over 3. So this is 2 pi over 3. 4 pi over 3. 5 pi over 3. Okay, now, to get to this point up here, I need to go over horizontally and up vertically. So the horizontal distance, right, is that the shorter or the longer distance? That's the shorter, so how much is it? 1/2. So how much then is the cosine of 60? 1/2. The vertical distance is the longer one, √3/2. So how much is the sine of 60? √3/2. For the 60s, for the 30s. Well, because now it's a different triangle. So before, the triangle looked like this. You went longer horizontally, √3/2, up shorter, 1/2. Now we're going over shorter, 1/2, up longer, √3/2. Okay. So to get to this point, horizontally shorter, negative a half. Vertically longer, √3/2. To get to 4 pi over 3, horizontally I go how much? Negative a half. So what's the cosine of 4 pi over 3 then? Negative a half. Okay, it goes with the negative. And then the sine will be, the vertical, negative root 3 over 2. So negative a half, negative root 3 over 2. The 300, I go over horizontally, 1 half. I go down much longer, negative root 3 over 2. So the cosine is a half, the sine is negative root 3 over 2. Okay, Sienna, can you close the door, please?
Negative, right?
Negative. Okay, let's do the 45s now. So for the 45s, what do we know about the 45s? What do we know about the horizontal and the vertical distance? Okay, the horizontal and the vertical distance for the 45s are the same. And it's root 2 over 2. Both of them are just root 2 over 2. So to get to this point, I go positive root 2 over 2, negative, positive root 2 over 2. Both positive. All right. So then I have this one. Oh, you know what? Yeah. So, okay. So this is 45 degrees. This one here is 45 away from the 180. So 180 minus 45 is 135. This one is 45 away this side. So 225 and then 315. Okay, so it's 1 pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Okay, so we're going to go, so for the pi over 4s, it's a 45, 45, 90. Same distance for cosine and for sine. So for cosine, how much do I go horizontally? Negative root 2 over 2. For the sine, how much do I go vertically? Positive root 2 over 2. So negative root 2 over 2, positive root 2 over 2. Here, I go negative root 2 over 2, negative root 2 over 2. Right? Again, one last time. What we're doing here is the route to go from the origin down to that point. Okay? The cosine is how much I go horizontally, root 2 over 2. The sine is how much I go vertically, negative root 2 over 2. All right, now, that's all we're going to do right now. Let's do some examples. Okay. All right, so let's do some examples. Suppose the terminal side of an angle intersects the unit circle at the given points. We're not going to do those right now. These are, okay. So, find the values of cosine and sine. So remember, cosine was always the first coordinate, and then sine is always this one. So cosine of theta is root 3 over 2. Sine of theta is 1/2. Now it says, then find the measure of the angle in radians and degrees, referring to the unit circle. So here's what we're going to do here. We have ourselves a unit circle. This angle, to trace out this angle, we have to go to this coordinate point. To go to this coordinate point, I go horizontally root 3 over 2. That's the longer distance. So I go a longer distance here, a shorter distance there. That's the angle that I've traced out. So if I go longer and then shorter vertically, that's the closest one to the x-axis. So that's the 30-degree angle, which means this is 30 degrees and pi over 6. Because it's the shortest distance from the x-axis, so it's only 30. Look at these angles here. You have a 30, a 45, a 60. Right? Those are the increments that it goes. Right? What angle is this? right here, 0. So the first one you hit of the special angle, it has to be 30. It can't be like 60 then.
But I mean, like, how did you know that I guess if you know the so we're gonna have to memorize.
No. Please don't memorize anything. Please. There's only 2 distances you can go. The longer and the shorter. That's it. If you go up a half, right? You're either going to go up a half or root 3 over 2. If you go up only a half, you hit the first one. If you go up longer, root 3 over 2, you hit the second one.
Oh, so if it's 45.
Okay, can I teach the lesson and then you can ask questions? Okay. All right. So here we go. Okay, actually for this one, I'm going to erase this one and I'm going to give you another one. Why don't we do negative root 2 over 2 and positive root 2 over 2. So the cosine here is negative root 2 over 2 and the sine is positive root 2 over 2. So to get to this point of tracing this angle, I have to go over to the left root 2 over 2 and up the same distance root 2 over 2. Now, if you go the same distance horizontally and vertically, that's got to be a 45-degree angle. Only for a 45-degree angle do you go up the same amount and horizontally the same amount. But the 45-degree angle here is the 135. And since it corresponds to the pi over 4s, it will be 3 pi over 4. Okay, now, everything that we have been doing until now has actually been leading up to what we're about to do next. And that is, to be able to evaluate these special angles. So what we're going to do now is sine of 135. Okay, now listen. The first thing we're going to do is you have to figure out where 135 is. So on the unit circle, $135 is right there. Now, we know that that's a 45, 45, 90. How do we know that? Well, it's because we know that the reference angle for it is 45. How do we know that? It's because that's what we learned previously. So we know that the 135 is a 45, 45 triangle. Now, I want the sine of 135. Remember, the sine is the y coordinate. In other words, if I want to find the sine of 135, all I need to do is figure out, to get to that point, how much do I need to go vertically up or down? So to get to that point, I go horizontally a little bit, and then I go up a little bit. So since it's a 135, horizontal and vertical distance is the same of root 2 over 2. So that's the sine of 135. Okay? Now let me tell you another way. How do you get to this point? You go horizontally a little bit and you go vertically a little bit. How much do you go horizontally? Negative root 2 over 2. How much do you go vertically? Positive root 2 over 2. So the sine is that vertical distance, root 2 over 2. Okay, now let's do another one. That's it. We're done. Okay, it's the y value. That's all. Okay, so now let's do 7 pi over 3. Now, this is a pi over 3. The pi over 3, we should all know by now, corresponds to the bigger angle, the 60 degrees. So here I have 1 pi over 3, 2 pi over 3, right? 4 pi over 3, 5 pi over 3. Okay, but I'm still not there. The next one here is 7 pi over 3. Right there, 7 pi over 3. Now, this is the big angle. That means to get to that point, I have to go horizontally a short distance, vertically a longer distance. Now, for cosine, I'm only concerned with the horizontal distance. Because that's the shorter distance, it can only be a half. So the cosine of 7 pi over 3 is just a half. In other words, to get to that point, I go horizontally a short distance of a half, vertically root 3 over 2. So since cosine is the horizontal, that's a half. Okay, now I'll take 1 or 2 questions before I move on. Okay, so 5 pi over 6 on the unit circle. Five pi over 6 is in the second quadrant. Now, pi over 6, is that the big angle or the little angle or the big angle? The smaller angle. So we're right here, 5 pi over 6. So tangent is opposite over adjacent. All right, now, to get to this point, I need to go horizontally a little bit and up a little bit. How much do I go horizontally if this is the bigger angle? Negative root 3 over 2. Good. And how much do I go up? 1/2. Good. So now tangent is opposite over adjacent. So this is 1/2 over root 3 over 2. These 2's will cancel. So I have 1 over root 3. Root 3. Oh, negative. This is a negative. Right? So negative root 3 over 3. Okay? So that was a negative root 3 over 2. You cancel the 2. Now you have 1 over negative root 3. Then it's root 3 over 3. It doesn't matter where you put the negative. It's all the same. Yes. No. Because for the 30, it's different. For the 60, it's different. Okay, let's just do a couple and then you'll know. Because I can't keep re-explaining. Let's just do a couple and you'll know. Okay, so the next one is a 5 pi over 3. So 5 pi over 3. Okay, 1 pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. Now we know that's the bigger angle. Okay, so here we go. This is what you were asking. So this is the 60 degrees. How do you go to that point? This time you go horizontally the short distance, vertically the long distance. So it's switched. Okay, so this is a half, negative root 3 over 2. Do you see how for this one it was different? We went longer horizontally. Here we go shorter horizontally, right? The sides switched. So here they're going to switch. Okay, so 5 pi over 3. Okay, so cotangent is adjacent over adjacent over opposite. 2's cancel. Negative 1 over root 3. Negative root 3 over 3. Okay, next, go ahead and draw that 120 degree. Okay, so 120 is in the second quadrant, but now that's the 60 degree angle. So to get to that point, is the horizontal the shorter or the longer distance? Shorter distance of negative a half. Secant is like cosine.
Oh, yeah.
Okay. So is secant cosine or sine? Cosine. So what is this going to be? So the cosine is negative a half. What's the secant? Negative 2 over 1. Okay, let's think about that one more time. The cosine is negative a half. Secant is the reciprocal of the cosine, so it's negative 2. Okay? All right, let's move on. Okay, negative 3 pi over 4. Go ahead and draw that. Let me know what quadrant you land in. Third quadrant. Good. Okay, third quadrant right here. Now, what kind of triangle is this? It's a 45, 45, 90 because it's a pi over 4. That means the horizontal and the vertical distances are going to be the same. Horizontal distance, vertical distance are the same. How much is that value if they're the same? Root 2 over 2. Fabulous. So now, is cosecant sine or cosine? Sine. So now, is it positive root 2 over 2 or negative root 2 over 2? Negative. Why? Because in order to get to this point, you have to go vertically down from the origin, right? It's vertically down. So it's negative root 2 over 2, negative root 2 over 2. So the cosecant, though, is the reciprocal. So negative 2 over root 2. Rationalize. Negative 2 root 2 over 2. Negative root 2. Okay, let me do one more and then I'll take a question. Okay, 480. Oh, where's 480? Let's see. Okay, so here's, okay, so you go one circle, that's 360. How much do you have left? 120, and that'll be in the second quadrant. Now, is it the big angle or the small angle in the second quadrant? Big one. Because 120 is here. It's 60 away from 180. So now, cosine, is that the horizontal or the vertical? Horizontal. Okay, to get to this point, I got to go short this way, long that way. Short is a half. So cosine of 480 is negative a half. Okay? Do you see how much simpler it is to do it this way than like what we were doing before with like the all students take classes and the blah, blah, blah. Okay? Because it's, you get this, yes and no. Let's just put it that way. Okay. All right. Now questions. So those are some good circles. So this one here is pi over 4. 3 pi over 4 will be this way, right? Because we're going in the negative direction. Okay, sine, is that the horizontal or the vertical?
I mean, vertical.
Vertical.
I knew what I was going at.
Sine is the, huh?
Vertical is going
Okay.
up and down.
Okay, to get to this point, okay, how do you get to this point from the origin? You have to go horizontally a little bit and vertically a little bit. The amount you go vertically is the same as the sine. That's the answer, right? That's what we've been doing. So horizontally, we go negative root 2 over 2. Vertically, we go negative root 2 over 2. So the sine is the vertical distance, negative root 2 over 2. Okay, 690. So, okay, so 690 minus 360, what does that give you? 330. So 330, is that going to be the big or the small angle in this quadrant? Small, because it's only 30 away from 360. Okay, now, this is tangent, so we need both of the sides. To get to this point, I have a horizontal and a vertical distance. The horizontal is the, what? Which one, bigger or smaller? Bigger. 3 over 2. How much is the vertical then? Right, negative a half. Tangent is opposite over adjacent. Negative a half over root 3 over 2. 2's cancel. Negative 1 over root 3. Negative root 3 over 3. Okay. So this next one is 17 pi over 3. Now we can keep counting. That's nice and fun. But there's also a shortcut, right? You can do like 1 pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3, 7 pi over 3. Okay, it's fine. But there's also a shortcut to do that. 17 over 3 in mixed number is 5 2/3, right? Is that right? So look. 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, and another 2/3 pi, we land in this quadrant. Okay? So, because you go 5 pi around, 4, 2, 4, 5, and then another 2/3. So we're in this quadrant. And because it's pi over 3, that's the big angle. So cosine, is that the bigger or the shorter? Shorter. So how much is the cosine there? 1/2. It's just the distance. To get to this point, it's the distance you would have to go horizontally. That's the cosine. So if you learn one thing is the following. Horizontal is cosine, vertical is sine. Okay? Press start.